Hey, the average Joe here. Hey, lately I've had some questions on some primary secondary systems. So we're going to look at the software and just kind of how some of those systems are set up and calculated. So here in the middle of this, these three layouts, you'll see I have a pipe that's typically called a dual or decoupler pipe here. I have over to the right. Where that pipe's green, that means that the flow can be set in different directions. You could also use a hydraulic separator in that same case if you didn't want to use a pipe to get the different flows in each primary secondary system. Here on this project, we have an 8-degree delta T, a 10, and a 12. And then the temperatures here at the air-cooled chiller are constant, 10 degrees, 44 to 54. With the 8-degree delta T, you'll see that flow, since the flow is higher out in the system there, the secondary system, we set that pipe from the top to the bottom. Here where the flows are equal, then there's no water going through that dual pipe or decoupler pipe. And then if there's a greater delta T out there in the system, you'll see that we need to set the flow from the bottom to the top. And then that in each of these cases, that GPM will mix with the return. The 44 is going to mix with the 56 and you get the 54 coming back. So that's kind of with the constant temperatures here at the air-cooled chiller, varying temperatures out the load. Now, if I happen to reduce this load, I'm going to come down to the bottom. I set up another scenario on my project manager just by going into it and setting another scenario there. My other scenario that I set up, I actually went in, I'll click on it now, and you'll see I varied the load, cut the load in half from 90,000 down to 45,000. I kept the varying temperatures out here. Then I went on the air-cooled chiller side and I set the delta T as 5. Since the load was reduced by half, I set the delta T at half, and you'll see that we still have a constant flow through each of the chillers. Sometimes people want a constant flow going through your chiller. And by doing that, we still have the flows that are out in the system and the mixing still taking place. So obviously there's a lower flow at each one of these pumps, right? And then there's going to be a greater flow on the bypass. I come back here and go by there. You'll see here there's 3 GPM there as opposed to the 10 that was being bypassed before. Anyway, so that's just going over kind of the basic systems here and setting up a primary, secondary system, being able to go in, set the directions of a pipe, and also creating other scenarios where you want to vary loads or vary temperatures to see how the system reacts. Hope this has been helpful. Hey, thanks for watching.